on est le numéro 1 de la production d'électricité. En France, on est encore petit, on a dépassé les 100 000 clients aujourd'hui. Félicitations à eux. Et on vient de gagner l'UFC Que Choisir aussi, donc on devrait grossir assez rapidement dans les prochains jours. Donc, on parlait donc cette fourniture d'électricité verte, avec un gros accent sur le service client, avoir un service client qui ne suit pas juste des arbres de réponse, mais qui répond aux clients, qui leur donne des vraies réponses, qui essaie de les aider aussi dans leur démarche de décroissance et de consommer mieux. Donc, c'est ça que les piliers. Une fois que tu as vendu ton électricité, c'est bien aussi d'en produire. Donc, on a aussi une grande branche qui est un grand pilier qui est de produire ton électricité verte. Donc là, on a un plan de 20 milliards d'euros sur de l'éolien offshore qu'on est en train de déployer d'ici à 2030 pour pouvoir fournir à 15 millions de foyers de l'électricité verte. Donc ça, c'est le deuxième pilier. Le troisième pilier, c'est ce qu'on appelle les services. C'est l'amélioration de l'habitat. C'est aller venir poser des panneaux solaires, poser des pompes à chaleur, améliorer l'étanchéité de vos murs pour pouvoir avoir un habitat tout simplement qui consomme moins d'électricité. Et le dernier, c'est un peu plus technique, c'est ce qu'on appelle la flexibilité. En fait, avant, en électricité, on va toujours avoir la production qui est égale à la consommation, sinon tout est cool. Okay. Et avant, quand on avait des pics de consommation, on avait un truc un peu magique qui était, je clique sur un bouton et il y a une centrale à charbon qui s'allume et qui pompe à fond. Ça fonctionne, mais ça pollue beaucoup. Donc aujourd'hui, avec les énergies vertes, on peut pas vraiment, on n'a pas un bouton magique qui dit vas-y, vent souffle, soleil brille. Donc on fait ce qu'on appelle la flexibilité, c'est de ne pas agir sur la production, mais bien agir sur la consommation des personnes, en les faisant consommer au moment où il y a beaucoup d'électricité verte avec du soleil, du vent, ainsi de suite. Tous ces piliers-là, c'est ceux qu'on a mis en place pour amener la transition énergétique dans un maximum de pays. Et tous ces piliers-là, ils auraient besoin d'outils pour fonctionner. Et ces outils-là, c'est ce qu'on va vous parler aussi aujourd'hui, c'est Kraken. Kraken, du coup, qui s'est séparé en plusieurs grandes parties. Donc, le Kraken Retail, qui est pour soutenir l'activité des fournisseurs de l'entreprise. Kraken Flex, qui est tout ce qui est soutenir tout ce qui est flexibilité. Donc là, on a des trucs qui sont assez marrants. On fait du pilotage de maison avec batterie de voiture électrique. Ta pompe soleil, c'est la batterie de ta voiture électrique qui recharge ta maison, par exemple. On a aussi des trucs qui sont un peu plus poussés sur du management d'assets sur un pays en disant bah, aujourd'hui, on sait que tu as beaucoup de soleil, tu as beaucoup de vent, recharger des grandes batteries et demain, bah, le marché il sera plus cher. Donc, vends cette énergie que tu as storée sur la batterie. Voilà. Et le dernier, c'est ce qu'on appelle Track and Field, qui est un outil qu'on va utiliser pour faire toute la logistique pour l'installation des panneaux solaires et des pompes à chaleur. Donc, c'est ces trois outils-là, et en fait, ils ont tellement bien fonctionné, ils ont apporté tellement loin qu'on a commencé à les vendre. C'est quand même c'est du software, ça se vend bien, et nos clients, nos concurrents, ils étaient vraiment très intéressés de l'acheter. Et c'est un petit peu ce qu'on va vous expliquer aussi derrière avec Kraken. Donc, on a commencé à vendre ça à nos compétiteurs. Donc, on travaille par exemple avec EDF en Angleterre, on va travailler avec Ion, on va travailler avec Origin en Australie. Donc, petit à petit, on est en train de devenir le numéro 3 mondial de l'ERP sur la partie vraiment retail et fourniture d'électricité, avec aujourd'hui 25 millions de clients et on espère dans les prochains mois, prochaines années, 100 millions de clients. Donc, on commence à être assez costaud. Ce qui a généré aussi 4 millions de lignes de code. Voilà. Ça, c'est dans les grandes lignes Topus et Kraken. J'espère que vous apprécierez la soirée et si vous êtes plus intéressés, après, on pourra vous remercier. Merci à tous et bonne conférence.
Le prochain speaker, du coup, c'est David Winterbottom, qui nous vient des UK. Donc, il va présenter Lessons from a Million Lines of Django Electric. Vu que le talk est en anglais, si vous avez des questions après le talk, vous pourrez les poser même en français et je vais traduire du mieux que je peux. Mais si vous pouvez les poser en anglais, c'est encore mieux et surtout, n'hésitez pas.
Je peux mettre la caption avec la traduction.
Okay, so I'm David, and I'm going to try and share with you some lessons from creating and building and looking after 4 million line Django monoliths over the last 8 years. So, Who am I? Well, I guess I have a little introduction down, but I'm the head of software engineering at Kraken Technologies, which is part of the Octopus Energy kind of global group. I've been there since the start, so that's around about 8 years. I've been working with Python and Django for maybe around 15 years, something like that. In a previous job, I did a lot of e-commerce with Django, and I wrote and then built this package called Django Oscar, which became popular, but I'm not really involved in the project anymore. I'm called kind of code in the hole on the internet, and I once did a good tweet, and I don't think I'll ever top that one. So yeah. Oh, and I also write the place where I publish most on the internet is a TIL site, like a Today I Learned website. Like, just random tip, highly recommend doing that yourself, just as a way of making notes of things you learn. Writing them down forces you to learn them a bit deeper, and then it's somewhere to refer back to. So that's something we've started doing a lot more work, actually. We have a Slack channel just for tech things that I learned today, and we'll even have a custom emoji. Anyway, digression over. TIL is really useful. So, what's this giant 4 million line Django monolith? Well, I guess that secret's already spilt, because it is Kraken, which started life as really just a simple website for the UK for a new energy supplier, Octopus Energy, and then it evolved. It evolved into an energy platform that other suppliers could use, both in the UK and in other countries like Australia and Japan. And it's evolved even more since then. It's now a general utilities or operating system or platform, if you like, which can be used in the energy industry, for electricity and gas. It can also be used for broadband and water, and it's kind of evolved into this wide-ranging kind of platform. Okay, so 8 years ago, I created a commit, a hello world commit. This is going to be awesome. I said, this is going to be Kraken, or this is what would become Kraken. And then 300,000 commits later, which brings us to about last week. And I then ran, there's a tool called Clock, C-L-O-C. I don't know how readable that is. I ran that on the Kraken code base, and there's actually 4 million lines of Python now in this repository, which is quite a lot. There's also, what have we got, like nearly 1 million lines of JSON, loads of HTML, TypeScript, JavaScript as well. But let's talk about the Python side of things. Just a few more stats on the size of this kind of mono repo that we have. I think we have about 500, or more than 500 contributors now. There's about 500 or so people working in tech at Kraken. Every time you merge a pull request within Kraken core, it runs on average about 165,000 tests in Circle CI, our kind of CI vendor. And we recently went over the milestone of having more than 100,000 merged pull requests. And fun fact, when you go over number 100,000, so you paste a pull request URL into Slack, which is what people do absolutely every day at Kraken. Slack expands the 6-digit number into a hex color, and so we're currently migrating from dark blue into the dark greens. Okay, so it's massive, but it's also been successful. That's what's enabled it to keep growing. I mean, Kraken is used in 9 separate countries around the world by 19 different suppliers. I think we have something like 45 million customers on it, or on contract to go onto it in the next few months. And at the height of the energy crisis, maybe a year, 18 months ago in the UK, something like 0.5% of the UK's GDP flowed through Kraken in that year. And it's still just a Django project. If you checked out the repo, you would recognize it. There's nothing magical about it. All this money which is flowing through it is a cron job that calls on management commands, which kind of pulls down people's direct debits. It's just a Django project that we all kind of know and love. Okay, so hopefully I've convinced you that we have this huge code base. It's been successful, And maybe there are some interesting lessons that can be taken away that you can take to your own projects, companies, that kind of thing. So that's what I'm going to try and share. I think one kind of principle is going to underlie a lot of the things I say in the next few slides. And that principle is kind of in the answer to this question. So when it was suggested I should do this talk, someone said, oh, maybe you could talk about, how did you design Kraken to scale to be this monster it's become kind of today? And I was thinking about that. I don't think we did. I think that, not primarily, the kind of our philosophy, right from day one through to kind of year 8 where we are now, was never to think, let's try and build for a huge capacity tomorrow, let's jump into microservices or something like that. What we always tried to do is to make it really good at solving the problem that we had right now, the problem of today. And then after that, we tried to make it easy to change. We tried to make it so that when we did have to add capacity, add features, do something different, change direction, it was going to be easy to do. And highlight that in purple because that is the thing that I'm going to talk about the most. This principle of trying to design things to be easy to change. And a really key part of things of making things easy to change is to keep them as simple as possible. And something we do at Kraken is have a kind of minimal viable everything policy to our technology, our code bases, and even our organizational structure, how we organize meetings, that kind of thing. It's a real cultural kind of pillar. Okay, anyway, on the first point of making it really good, I'm not going to talk a lot about that today. That's a tech talk, really, about how you build an effective product. Maybe I'll have some time at the end. I can touch on a few practices we have around that. But let's focus on this idea of software that's easy to change. So, what does it mean? Why is it interesting? Well, what do we actually mean when we talk about high quality software? What makes software good? If you're reviewing someone's pull request, what makes you think, oh, this is, I like this, I enjoy reading this, reviewing it, working with it. Well, first of all, the code we write and the things that we ship in Kraken, they've got to work. They've got to do what they're supposed to do, be correct, kind of meet their requirements. Okay, that's a given. You got to do that. But after that, what's most important? Well, I will argue, and I'll expand on this on the next slide, that the next most important thing is to design things to be easy to change so that they can be extended, built upon, debugged, even deleted easily by yourself or your colleagues tomorrow, next month, next year. Of course, maybe a third item I should have pointed out is we need to perform adequately. Absolutely, can't deny that. But being easy to change, I would say, has been, certainly for Kraken, has been much more important. So let's unpack this easy to change question a bit more with this kind of umbrella diagram. So I've written, is something easy to change at the top? And I think as you drill into that question, you'll stumble upon all the things, all the kind of software design principles you've come across, which indicate high quality software. So if something's going to be easy to change, it's got to be easy to understand, which means you can read it and things are well named, whether they're variables or functions or classes or packages or modules. There'll be kind of commentary, comments explaining why something's done, like strings which explain to potential users of that function or a class or module, what it does, what kind of expectations are, general things that are simple, that are easy to change. But it's not just about reading it now, how it is at this particular commit. It's also really important to understand why it's evolved that way. Why is this function built this certain way? So it's easy to kind of do detective work on the code base. And Git lane is the key tool there. So a code base that is easy to change is also easy to understand and to analyze its history to understand the direction that it's moving in and why certain decisions have been made. And so that's why you might look at commit messages, self-contained commits. I'll talk a bit more about those in a few slides, and audit trails. Okay, so that's kind of readability aspect. But also, it's going to be easy to change. We're going to be able to change things safely. So you're going to need a test suite that's going to prevent regression. When you want to make a small change, extend a feature, you don't want to have to change 46 files all over the code base. You want to be able to kind of make a change in a small area, which will show that you've got kind of good degree of reduced coupling, high cohesion. It's going to lead you down the road to the kind of single responsibility principle, and then further to the kind of solid principles, of which the X is the single responsibility principle. And of course, if you're going to be able to change things, easily, you're going to need to be able to deploy them safely. So using continuous deployment to be able to deploy really small releases that you can put in production, put in front of users, observe their behavior, and kind of learn from that, change direction. And maybe that's backed up by a series of health checks to make sure that you never deploy anything that's broken. Anyway, so my point really here is this kind of question about when you're writing code, making decisions about tech, always thinking, is this going to be easy to change in the future? It's a great guiding principle for building an effective project. Okay, so let's get into the details a bit more about how we actually build Django projects that are going to be easy to change. Start with something that's been really important at Kraken, which is an ever-evolving set of conventions, how we want to do things, how things should be structured, bookends and kind of anti-patterns to avoid. Yeah, so this has been tremendously important. So we have a GitHub repo full of our conventions, and it's grown enormously over the years. We have whole pages of them on Django, on Python, on application design, things around Git and code review and database migrations. And there is a public version of this. You can go and check it out. It's on this kind of Octoenergy/conventions on GitHub. It's a slightly curated version of the master set, which does have some kind of private details in, so that now and again we port the good stuff back to the public repo. But that was done quite recently, so they're relatively up to date. And so these are tremendously valuable in terms of ensuring kind of consistency through the code base. When you've got 500 people working on it all around the world, different time zones, you kind of don't want your code base to fragment too much. And the people in Paris are doing things one way, but the people in London are doing it in another way. We want it to be consistent so that any developer can jump into any part of the code base, understand it, and find it easy to change. So let's have a look at a couple of examples from there. I just picked a couple of simple ones, kind of thing that's in there. This is from the kind of application design section. So example convention 1, you shouldn't be able to induce like a 500, like internal server error from a Django application. So examples, I suppose, anti-patterns where you can do this, like here is loading a model instance and kind of assuming it's always going to be there in the database. Assuming if I look at from this ID, it's going to be there. Of course, it might not be there, and so that might raise a does not exist exception. You can easily work around this by using kind of Django's shortcut, get object source 404 or something like that. But fundamentally, I can look at that and see a way of inducing a 500. So that would be a fixed thing. And another example might be assuming that some kind of webhook view, which gets given gets posted a JSON payload, that's always going to be valid JSON. That's not always going to be true. You need to handle the case where you're going to get a JSON decode error. Another thing might be assuming that there's always a particular query parameter present, or that query parameter is always an integer. These are the kind of things. And so one of my conventions is you should never be able to induce a 500, and that's useful to code reviewers. So code reviewer might be looking at someone's pull request. Oh, hang on a minute, you're not thinking about the JSON decode error. You need to do this, like a link to the convention which explains it in detail. You don't need to have a long discussion about it in that pull request. It's just saving people time, helping them be more productive. Another simple one would be if you've got a model, the kind of dunder string method should always uniquely define that particular model instance. And the reason for that is if you use a tool like Sentry, which when it kind of prints out the information in the stack to help debug, it's just going to print out the string version of that model or a model instance. And if it's not unique, it's really hard to debug. You don't know exactly which instance it's talking about. It's harder to reason about what actually went wrong. Really simple. Just put the primary key in there in the dunder string. That's always going to let you sidestep that problem. Okay, so those are quite simple examples. Go and have a look at the repo if you want to see some more interesting ones. And we'll touch on another one in a second. But let's talk a bit about enforcement. We've got 500 people all around the world. How do we make sure people are actually following these conventions? Well, part of it's kind of political and the kind of communication thing. We'll make announcements. We'll do talks. We'll persuade people this is the right thing to do. But that only goes so far. What you also want to do is use static analysis. So a tool like a linter, like Flake8, Rough, Fixit, which Rough might not be the best example of that, but a tool like Flake8 is what I'm really talking about, where you can write a custom linter that looks for your particular convention. And so when someone pushes up a pull request that doesn't follow the way we want to do things, the continuous integration service is going to say, oh, hang on, that the string method isn't unique, something like that. Fundamentally, computers are much more reliable than humans. It's much more efficient for your CI system to enforce this kind of thing. We've done a lot of this at Kraken. We do a lot of static analysis. We've written loads of custom linters using Flake8 mostly, but we have now in the process of actually switching to Rough. It's harder to write custom plugins as far as I know at the moment in Rough. So we actually use a lot of Fixit, which is like I think it's a Facebook-sponsored linting package, which again lets you do the same kind of thing. Lets you write custom linters that enforce your conventions. We even have some Python tests. We have a test that checks that every one of our management commands has a functional test that runs through it. And that's just using some simple Python, file discovery, find all the management commands, look for a functional test. If there isn't one, we're going to fail the kind of build, and then developers will have to kind of work that out. Okay, and a nice complementary tool to using custom linters is to use a kind of ratchet mechanism. So suppose you come up with a new convention and say, oh, well, all our actually I can't remember a good example. Some change. I'm going to talk about this in a bit later. So I don't want to spoil the surprise for that one. It's a new convention where all the code needs to behave a certain way. There's already 800 places in the code base that need to be changed. You don't need to change them all on day one. The way we've always done this at Kraken Tech is we introduce the new convention, and we'll find a kind of ratchet mechanism that stops people doing the wrong thing with the anti-pattern anymore. So we cap it at 800. Maybe that's by just putting kind of comments on every line, like no QA, or lots of these kind of stuff as well to like comment system. We actually kind of ignore them, and then we'll find a way of kind of whispering to development, urging them to do a little bit of work of fixing these errors as they go. And so Flake8 has this minus diff option. So we've written custom linters that whenever you push up a pull request, it's just going to look at your diff and then try and apply the new conventions there. And that forces developers to do a little bit of cleanup, help refactor away some of these the old way of doing things, move things onto the new way, bit by bit. Over several years, it doesn't matter. It doesn't have to take place quickly. But this creates a kind of burn down project. And this has been really effective for us. Now, I'll flesh this one out a little bit more in a minute when I talk about technical debt. But for now, I think I just did 2 slides there. I did, because I now want to talk, move away from conventions, talk about application architecture. So how do we kind of lay out Kraken as a kind of Django project? And a good way to illustrate this is by talking about the third convention of ours, which is broadly to avoid using model-based things in Kraken. So Django is, it's famously the framework for perfectionists with deadlines. And it's really good at building CRUD apps, where it's kind of a fairly thin wrap around the database really quickly. You can declare your models, and then things like forms, serializers, views, graphene things can introspect those models, dynamically build themselves a form based on the model. And that's amazing for productivity, but not brilliant for building a really large Django project. Generally, so for instance, like say model forms, you're trying to do some kind of create a new customer. Oh yeah, there's an example. So a new kind of customer sign-up journey, you can have a form with all the fields you've got, you collect from a customer, and then the kind of road you're going down on the model form is you've got a kind of save method on the form instance. And your temptation is to put more and more kind of business logic into that method, or maybe you're overloading the save method on the model, or maybe you're kind of putting application logic in the view and the form valid method. All of those places are going to take you to a hard to maintain place over time. It's probably fine if it's a small project, but when it's a 300,000 commit project, it's not the direction you want to be pointing in. So even though it's mildly controversial, and we are moving against swimming against the current of Django a bit here, we kind of prevent that and say, don't ever do that. Just use plain forms, plain views. Don't use things that introspect the models. Because in a sense, Django doesn't actually provide a natural home for kind of sophisticated kind of blocks of application logic, like signing up a customer. So in Kraken, typically, if a customer signs up with us, we've got to do lots of things. We've got to update the database in several ways. We're going to create a customer record, an account record, maybe a property record. There's several tables getting updated. We're going to want to talk to some third-party vendors. We're going to maybe talk to a payment gateway to check their payment details. We might be talking to some industry service to check their kind of meter details or something like that. And then we might be going to send the emails as well. So a whole load of stuff going on. You don't really want to put all that in the kind of save method of a model form. So what we use is something called use cases. A use case it's not a Django thing, it's just the kind of concept that we refer to. And it really just refers to that whole kind of operation of all those different things, talking to databases, talking to third-party services, publishing logs, publishing metrics, and the use case encapsulates all that. It's normally just a function in a module, really. But it's also responsible for kind of orchestrating, which means it's responsible for opening database transactions and knowing when to roll back and commit. Maybe you're talking to multiple databases. It needs to think about the kind of transactional behavior. Similarly, it orchestrates this interaction with other third-party services. Now, so I talk about here that they're agnostic of the interface layer. So what that really means is they're agnostic of the kind of thing that calls them. So when you've got a HTTP request coming into a view, data's valid, then we call into the use case. The use case should know nothing about how the thing that's calling it. It shouldn't know anything about HTTP, about requests, about cookies, about sessions. Because you should always be thinking when you're writing a use case, well, what if I want to call it from a command line application, where there's no such thing as the kind of HTTP thing. Or maybe it's been called from like a salary task. And indeed, Kraken has several interfaces, several different websites, like a webhook site, an API site, a kind of support site, sometimes a consumer-facing site, all in the same repo. So it's got multiple kind of URLs.py, if you like root URL confs, all in the same project. We manage that using Django configurations. The key point is there's like what we call an interface layer, which has these kind of different websites into it, and that talks to the next layer down, which contains use cases. And that brings us to our layered architecture. This is a bit of an overwhelming diagram. Let's try and talk through it. Let's go from the top down to the bottom. So you think about a kind of a request or some kind of event, an external event coming into Kraken. Could be a HTTP request, could be like someone invoking a salary task or a command line thing. Then that's going to come into all of these interface components. So they're going to call this use case, the register new customer. That's going to open transactions with databases. And then it's going to call, well, we have another layer below it called the domain layer, which has kind of reusable kind of functionality that lots of use cases might want to do, like just send an email or update a customer record, something like that. And down at the very bottom, we have two layers, which is the data layer, which just has the Django models that we all know, but they're very thin. We don't put methods on them that know how to do lots of things. They're really just quite simple data structures. And then you also have a kind of vendor layer, which knows how to talk to third-party services. But we have this direction of dependencies where the interface layer knows about the use case layer knows about the domain layer, and so on, but never the other way around. And we can enforce this, well, actually, I think I've got one more thing that lies on here. So these two middle layers aren't really a Django-y thing. There's no kind of module created by Django that naturally you put these things in. This is something we've come up with, this layered architecture, and it's where all our kind of application logic lives. And so a nice thing you can do to enforce this structure, which is really just about what module can import what other module. We use a tool called Import Method. It's written by David Fredden, who also works at Kraken Technologies. And this enforces the layers in your application. It kind of says that a use case function is not allowed to import from like a views.py, because that's the layer above it. And you can write a really simple ini file. You can declare your layers. The way you declare it even looks like the layer diagram. That's probably a little bit too small to see, but I've got a little kind of thumbnail on the previous slide next to it. You can see it kind of looks like the same layer structure. And that's been really useful. And if you're interested in using a layered architecture in your own application, strongly recommend checking that out. Okay. And so, the overall thing, I suppose, we're seeing in such a big project as ours is that we're squeezing Django. When we started, Django was our boss. It told us where to put things. So you create apps, you put your views here, your models here, not sure where you're going to put your business logic, you might end up putting it on, somewhere slightly inappropriate. Or we'll say, actually, no, we'll come up with our own architecture, thank you, Django, and we're going to just use you for interface layer concerns, HTTP requests, sessions, templating, and we're going to use the ORM. We're going to use the models, those ones that talk to the database at the other end. Okay, so that's the end of that section on architecture. I've got about 5 or 6 minutes left. I'm going to run through some useful practices that have really helped us look after this big code base over the years. They're not necessarily tied to Django, per se. Okay, we do continuous deployment. I'm not going to spend long on this, but I think most people know the benefits of this. We deploy about 150 times a day on a work day, once every 9 minutes, and that helps us ship things in really small changes, listen to our users, and change direction quickly. This classic kind of agile way of working. Okay. We're really hot on audit trails, on self-contained commits, which means that commits which, after every commit, the whole test suite should pass. After every commit in our mainline branch, this is, you can deploy it to production. We don't break things in commit 1 and fix things in commit 2. And we use Git rebase a lot. Everyone uses interactive rebase to squash, reorder, rearrange their pull requests before they merge to our mainline. That gives us a really nice audit trail in our mainline branch. And the kind of nirvana we're aiming for is you can go for any line of code and track it. You can do git blame on it. That'll take you to commit. Really nice written commit that explains exactly why. That will link to a pull request. The pull request will link to a ticket. Now you can say, okay, what was the actual success criteria we're trying to do here? The ticket will then link to the Slack conversation where someone said, oh, I've got an idea. Why don't we do this? So for any line of code and tracking, you should be able to walk back, reverse back to the actual original idea where it came from. Of course, that's not true of every line of tracking, but that's what we're aiming for. And that's amazing when you have that. In terms of keeping your code base easy to change, easy to understand why something is done a certain way. Okay, here's another one. This practice is about documenting things in a deeper, more permanent place. Okay, so imagine you've submitted a pull request, I've reviewed it, and I've asked the question, why are you doing it this way? What are you going to do? Well, what you could do is reply in GitHub and say, oh, I did it because of this. And that's in the GitHub comment. That's kind of lost forever. People in the future aren't going to find that, well, not easily. So that's not so good. So maybe a better thing you could do is jump back into your editor, add a comment in the code, say, oh, I'm doing it this way because of these reasons. And you can push that, rebase that back into the pull request. Brilliant, okay? That works nicely. But even better than that, why not kind of rework your code in the first place so it doesn't beg a question? Restructure it so the question is answered by the structure of the code itself. And that principle of, rather than kind of answering in the nearest, easiest place, but trying to find a deeper way of documenting something is really powerful. And this applies in Slack as well. A lot of the time people will ask, always asking questions, rather than writing their kind of answer in Slack, it's better to go and update your documentation and then just link to the documentation. And this kind of, it's like, this practice kind of compounds over time, and you'll find that your documentation sources get much better if you follow this practice, and similarly with your code base. Okay, so final section just on paying off technical debt, which I think is quite nice. So we incur technical debt, same as everyone. We have short-term pressure, we take a path of least resistance, we make decisions where we were ignorant about the wider context, fine. The art is knowing when to incur technical debt and when to push back and say, actually, this is the foundations of the cathedral. We need to build these properly, we need to spend a bit more time. How do we pay it off? 2 practices. First one, fairly obvious. We have a day a month set aside, Kraken Spa Day. It's a spa day for the code base. And we go and clean things, sharpen the tools, upgrade Python, refactor stuff, fix flaky tests, all this kind of thing. Okay, that's very straightforward. More interesting practice, the scouting rule. Scouting rule is always leave the campsite cleaner than how you found it. So imagine you've got a ticket, you're going to branch off the main line, you're going to create a pull request off your branch. Rather than diving straight into adding that feature, spend the first couple of commits just making the code base in nice place. Factor out some of those, that burn down chart we talked about before when we're moving from one convention to a new one. Just spend the first commit or 2 making it, refactoring and moving to that new convention. There's always things to do. There's always things you can improve. Make it easy to add the feature that you're about to add. Improve the tests, improve the documentation, and then add it, and then load it into the main line. If you get used to kind of just folding a small amount of kind of technical debt payoff into every pull request, again, the value adds up hugely over time. It's more powerful than the once a month, once every so often kind of spa day approach, although that's good as well in its own right. I've got a really nice example of showing these two things together. So maybe about 2 or 3 years ago, someone made a proposal, we should use type annotations. MyPy, whole cracking core, 4 million lines. I suppose it's only maybe 2 million lines at the time. We agreed on that, yes, we're going to do it. We went for this ratchet approach where we kind of introduced a custom flake-8 linter, which said all new pull requests are going to have to add type annotations to the code they touch. And then that meant that every time someone was doing a pull request, they were going to do this kind of scouting rule of adding a few type hints. And then on spa days, you might have a bit of a blitz, and people are going to put some energy into it, they might be able to get to a whole load of them. And this graph shows the number of lines of code in cracking core that are missing a type annotation over the last year. You can even see the bit where I broke the monitoring in the middle. And so, sorry, I know that actually is unreadable. It's 26,000 lines at the top of the y-axis. And you can see it coming down fairly steadily. And that's the kind of scouting rule, people making changes in every one of their pull requests. And these little spikes you can see on the spa days where we've just put a bit more effort into it. We've moved it a bit down. I think we're down to about 15,000. We're going to have a party when we get to 0. And so I think that's quite a nice graph that illustrates our two factors around technical debt. Okay, so that was all I could squeeze into half an hour. Let's just quickly recap. I'm slightly obsessed with this idea that high quality software is easy to change. I think that's really important. Monolith isn't a dirty word. Can be used to build an effective project. That it underpins a fast-growing companies like Octopus Energy, like Kraken Tech. To make a large Django or Python project easy to change, here are some of the things that we have done, like shared set conventions, concentrating on use cases. I think that's a really nice pattern. Even if you don't buy any of the other stuff, layered architecture, just start thinking in terms of use cases. I think that's really, really important. I do that in all my projects now, whether it's Django or anything. The layered architecture is really useful for big code bases, especially backed up by the import linter package. And yeah, making a lot of use of static analysis and ratchet mechanisms can help you improve things, even over a huge code base, slowly kind of drip feeding changes into your project. And the kind of slightly disparate stacks of other practices I recommended were continuous deployment, end-to-end audit trails from Git blame all the way back to Slack or whatever your kind of track tool is, documenting in a deeper place, and then paying off technical debt in a kind of business as usual, do it every day approach where you don't have to ask the manager permission. Would be a slightly crucial point. I'm fairly sure that is the end. It is brilliant. So, does anyone have any questions?
So, as I understand, you're building tools all the time, right? For making this change.
Right.
So it's more of an organization question, I guess. Where do people building these tools? Is there a team that's dedicated to this? Where is the
question? Well, until recently, we've never really had a dedicated tool for that. We've had some people that have had more time. I suppose a bit like me, who can spend a bit more time on tooling, but most people do it as part of their general workflow. If someone says, we need to write that, we've got this new convention, we're going to change the architecture, we need to write custom linter, that will generally, that team will absorb that, and maybe it takes someone a day or two. But I think we've managed to convince some of the product managers that that's an absolutely valuable thing to do. That it doesn't have to be a real kind of, oh, no one's got time to do it, we have to ask permission all the time. And also the spa days. A lot of time we'll come up with an idea. Oh yeah, we really should do this. But okay, I'll write that out. We'll do that on the next spa day. So that's those are the main approaches. We also do a kind of guild system, copied a bit of Spotify. Whatever belongs to a team, you work in the the French payments team or something. But then you can also join guilds, and they are responsible for kind of cross-functional topics like documentation or test suites or deploy pipelines or accessibility, and they can oversee that kind of aspect of our technology. And they'll get together on spa days, they'll have their own assignables and tickets, they'll talk all the time. Oh, we've got this problem with the deploy pipeline, we need to change it, we need to think about how we're going to deal with flaky tests, something like that. And so guild systems, it's just having the Slack channels that are dedicated to talking about documentation, for instance, are really invaluable as well.
Yeah, very interesting talk. Thank you. I have a question more about. Thank you. I have a quick question. I think I'm missing, like, I'm not understanding what you mean by use cases.
Sure. I suppose the best way of thinking about it is if you're writing an application that needs to just perform some action, even if let's just say think like register a new customer. So they're going to fill in a form, it's got their name, their address, and their bank account or something. It's a good way of thinking about it is imagine you've always got to have a website that does that, as well as an API site that does it, as well as a command line management command that does it. So you can't put any of that logic around doing all those things in the view or in the management command or in the view for the API sites. But all three of those kind of interfaces need to do the same thing, like the same use case. So you would kind of just create a module somewhere, create a package called use cases, have a module called registration, and it's got a function called create customer. And all three of those interfaces are going to call that one function to do all the things that need to happen for creating a customer. And as I said, it could be open and it's open in transactive databases, it's talking to third-party APIs, it's right into the database. So that's the kind of use case. And it's no massively spectacular thing. It's just a really useful structure because it forces you to not put any like HTTP stuff in there. You can't talk about cookies in that use case because it could be called from the command line, which doesn't have the concept of cookies. So it makes your views and your management accounts really thin because all they do is translate from the language of the events, like HTTP or command line options and arguments, translate that into the language of the domain. So they're talking about names, properties, and what have you, And so I think it just puts a nice pressure to kind of create an application which is nicely structured. And when you do this a lot, if you just look at the list of your use cases, it's like register new customer, change address, customer leaves. It's kind of a list of everything that your application does, if you like, speaking at kind of in the domain level, in the same language that you talk to your business analysts. So, so it's really just a convention around functions and fables and files. It's nothing special, but I find it tremendously useful.
Yeah, thank you. Very clear.
Yeah, so thank you. That was very impressive. I have two questions. What about migrations? Do you have any? It must be difficult at this scale. So how do you do that? I'm thinking also, especially for a CI, when it has to run all the migrations to run the tests, maybe. I don't know, like that.
No, we don't because it takes too long.
Yeah.
There's a trick you can do. We use PyTest, Django, and I think it has a skip migrations option that just does the old kind of syncdb command, if you remember the command Django, where it just looks at the models and turns it into one SQL statement and runs that. So that's the second question. Yeah, database migration. If you look at our incident reports over the years, one of the most common themes has been schema migrations because it's really easy to shoot yourself in the foot. We've put loads of effort into tooling. We have our own custom migrations commands that will look out for the classic anti-patterns. And you have to put we've got a custom option, minus, I definitely know what I'm doing kind of thing, if you're going to do some of these things. And so we have learned the hard way. Yeah, there's lots of ways that you can deploy migrations in a table locky, downtimey kind of way. We have a massive set of conventions around if you want to add a field, rename a field, drop a table, follow exactly these instructions. We've built loads of tooling around this. We have something which will always print the SQL from your migration in the pull request. you have to get a review from the databases guild if you're doing like a migration. We've also at the moment where we have all the current schema from some of our production environments, and it will do the explain, look at a query plan for exactly what your migration will do, so you can see if it's going to kind of take an exclusive block or something like that. And that's because we have different versions of Postgres and some patterns, you know, that sometimes throws up some interesting ones. So, yeah, I can tell you some more stories about serialization.
A quick one. Do you have any pushback with type hints? Because they are, I mean, with Django, it's not always easy because there is so much dark magic with
Django steps, yeah.
So how do you handle that? I guess you're going to say that people don't use much objects and the managers or query sets.
Yeah, we have an ongoing battle to try and upgrade Django stubs, yes, because the query sets and managers is definitely the pain point. We find overall find them really valuable. So they catch a lot of the kind of null pointer exception kind of errors. And so yeah, I think after a while you can't almost imagine life without them. You get really used to just having that kind of crutch telling you what's being passed in everywhere. Especially I suppose when you start introducing a lot more custom types. You know, it talks about this use case layer, and you often might introduce new types as you talk between the layers. And then again, the type system becomes invaluable. But yeah, it's still not easy. It's another, as I say, it's a spa day thing. We have people working on just, I think the missing one's also trying to work out how we can upgrade. We've got someone who's just working quite a lot of the time on MyPy directly. There's an underlying bug which is causing us a lot of problems there. So it's not easy, I suppose, in a big project, but I definitely say it's
doable. I have another question. How long does your CI take to run?
Good question. Some average time from like merge to deploy is probably about 45 minutes, which is longer than we'd like it to be, certainly. We used to deploy with AMIs in AWS, so you'd use like Packer to bake the AMI, familiar with that side of things. That was quite slow. So we switched to Kubernetes, so we build Docker images, that's faster, but we still have a slight problem with integration tests, you know, ones that spin up the database. And some like our Australian team have got loads, and they're running that our Australian integration test. It's like 22 minutes. So that's a spa day project to try speed it up, parallelize it, vertically scale. A lot of effort actually for us at the moment is going into conditional test running. We look at the diff, what's been merged, and say, okay, what tests do we need to run? So moving away from a kind of completist, not just sleep at night, then you've run all 160,000 tests, to a more pragmatic, that's only run 40,000 tests and it takes half the time. RCI bill is really expensive as well. Anyway, I guess maybe I should field questions afterwards. I don't want to take any time.
We have some also from training.
We have more time, 2 more questions.
Yeah.
Let's do it. 1 or 2 more? Oh, yeah. Should we do?
You were talking about splitting code before your implement feature. Don't you fear when you split there could be a twisting intention in reading the code? You know, maybe this feature should do it that way because we did that way, but when you realize sorry, the other developer was thinking about another idea to use that, you know, or maybe the integration is
it's the scouting role, but
about the scouting. Just don't you think there is a problem with there could be a problem with the way the new developer that put the feature will understand the feature itself, and it works in the mechanism generally.
Just a little bit. So you say that a new developer, there's a problem that if they do the cleanup bit, or they spend the first 2 commits, say, what was the problem with that?
I mean, you read the feature, you see it should have been made this way,
and maybe it was not the way the other developer was thinking about it. I mean, maybe, I don't know. I'm not really familiar with that happening a lot. There's always going to be, slight misalignment issue, you know, and sometimes we always try and get people to get feedback really early, especially when they're new. Like, we want people to just, as soon as they've got like a commit or two, put a pull request, you know, just, it doesn't matter if everything's broken, but show it to one of your teammates and just kind of say, am I going in the right direction? Because yeah, if you don't do that, sometimes someone spends 2 weeks going in the wrong direction, and then they ask for a review, and they're wasting everyone's time. So maybe we do have a problem. I don't know about it happening a lot, but we try and have some practices about especially getting feedback really early for new people to stop people kind of marching in the wrong direction. And there's one more question.
So I guess with 4 million lines of Django, the answer to the question is probably no. But since you're moving out of the Django intended way of working, have you considered using dedicated modules for the lower part, like the ORM and stuff, and dedicated other modules for the HTTP, CLI, and stuff?
Yeah, definitely. I mean, in a weird kind of way, we kind of want to design trackers so that we don't use Django at all. What the direction we're moving here is slowly squeezing it into little pockets. Maybe one day, yeah, we stopped using, you know, we switched to SQL Alchemy. There is a lot of people are talking about that. I don't know if there's a book called Python Architecture Patterns by Harry Kurzweil and Bob Gregory, which lays out a really nice architecture. That's quite hard to do in Django. You're really swimming against the current by trying to do that. That uses SQL Alchemy to actually, I'm trying to do a short version, invert the layers where the data layer depends on the domain layer as opposed to the other way around. And you can use SQL Alchemy has a data mapper pattern built into it to do that. And a lot of us would secretly love to get to that architecture, but there's a huge distance from where we are to where that is. But broadly, yeah, philosophically, we are moving towards a world where it's easier and easier for us to drop Django. You know, I don't actually get rid of it in practice. I can't see us getting rid of it ORM. Okay, so that was 2 questions. Any more questions, please grab me afterwards. Thank you. It's kind of like different according to new sources, which is quite similar to what
We like to have a few as well.
yeah. That's good to translate to other projects. So that's lots of people that you wish there's not much of it is that easy to translate. Think about job description.
It's the entire screen.
You the computer and the mic.
Yeah.
Okay.
I remember how to do it.
And then you have the microphone just on the table.
I think we're gonna get this. Do you have a microphone stand? If not, I'm okay.
Oh, I don't have.
Can you hear me? Yeah. Okay, awesome. Okay, I've been taught to project my voice, so when I speak, I do that. So if I start to get too loud, please do this. Right. So I'm gonna tell you about a package that I extracted from Kraken that David just told you about. My name is Daniel Roy Greenfeld, and if you don't know me, I'm also sometimes known as Pi Danny. We don't use that so much because I like to code in other things. For reference, sometimes people think all I do is Django, but really I think of myself as a Python developer. I'm the coder at Kraken Tech. I've also worked at various startups over the years and NASA and other US government agencies. I'm a co-author of 2 Scoops of Django. I'm a co-maintainer of Cookie Cutter. My wife started that and a few other big things. I also started Cookie Cutter Django. I co-started Django packages, and Django Crispy Forms originally was a project that I started when I was at NASA. So that's my claim to fame. I haven't used it in years, but I can still claim to be crazy. Okay, and then if you like David's talk and you like my talk and you're like, oh, that sounds cool, then come and join us in our mission to save the thing. We really like that. All right, this is my first time in Paris, and I'm so excited. In Americanese, we'd say I'm stoked. You know, I did come all the way here from London to tell you about DJ Notebook, so it's really important that you try it after this. And I'm telling you, I'm struggling here. It's so hard. Like, my waistline is suffering. I'm drinking a lot more than usual. The art industry. So, and again, I'm doing this for you, not for me, because I want to tell you about DJ Notebook. And yes, my mission today is to get you to stop using Shell Plus from Django extensions and instead use DJ Notebook. And before you think, oh, this is a slam on Django extensions and Shell Plus, it isn't. This is building on top of it. I'm standing on the shoulders of Django, or we are, me and the other people working on the project. So yeah, it's a wrapper. It essentially is a wrapper around Shell Plus that uses as its method of communication, its interface is Jupyter Notebook. And it makes it trivial. If you've ever tried to use, so if you ever use Django extension Shell Plus, in theory, you can do add a flag to Shell Plus, which is -- notebook. And I've never been able to get it to work. I've never seen anyone able to get it work. And I believe anyone who claims to have gotten it to work is just saying that because they're afraid to admit weakness. It's okay to admit that you can't get it to work locally. It's extremely brittle. But what we've done with DJ Notebook is we've made it trivial. You import a function called activate, and with relatively simple projects, Kraken's a special case, you can just do, you import activate and you just call the function and it just magically works. And there's been a lot of work to make that happen. And it works everywhere. One of the things I had until recently is I didn't want to use Jupyter Notebook because I don't like coding in a web browser. I prefer to code in VS Code. And you can use Jupyter Notebook or DJ Notebook in VS Code, PyCharm, Emacs. Then we have instructions for some of these. If you use Emacs or Vim and you want to contribute to the project, you try it out. If you want to document that, that's a pull request. So yeah, anywhere where Jupyter Notebooks can be run, you can use DJ Notebook. It's another one of our design goals, or I guess mine or ours, I'm going to say ours because it's a community now, is we want to make it easy to extend. If you've ever looked at the source code of Django extensions, you're like, oh, I'm going to make this change to it. Yeah, I'd much rather work on a 4 million line monolith than Django extensions. The Django extensions is a lot of code by a lot of very clever people, and it's very hard to change. So because of that, with DJ Notebook, we're getting a growing list of extra features, and I'm going to tell you about them right now. actually, I think instead, I'm just going to show you. So, all right, demo time. Okay, so as normally what I'd be doing is I would be doing this. Okay, so I can do it. This is actually VS Code. You can see there on the left is the file explorer. But what's that? Oh, yeah, I can do that. Okay. So I can try and flip this down and then pick it up. And if that doesn't work, I will use the other instance of this, because I have two versions of this demo. One is I'm actually going to code in front of you. That's going to require me putting down the microphone. But if that gets awkward, what I'm going to do is I'm going to do the one where I've already typed it out. But I do want to do a live demo. I know that breaks the rules of giving talks, but I like breaking rules. So let's do it. Yes. Abracadabra. Okay, so this is Jupyter Notebook. You can see if I click the edit thing, that actually pulls up Markdown. And I'm going to, because this is VS Code, the usability of this is so much better than the web. So I'm going to activate DJ Notebook. So I'm going to do from DJ Notebook, import, activate, and then plus equals activate. And this should, okay, it has started. So it's actually running now. And if I create a new module right here, what's next up? Okay, so I'm going to show you that right now I can get, let's see, from Django.contrib. There we go. Okay, so we'll use code completion. So if I do user.objects.all, okay, you can see that I have a working query set of the users. In this case, it's me, my wife. That in itself, getting Django to work in Jupyter Notebook is a little bit of a trick, but I'm going to do it and show you something even better. Here we go. So this plus object contains everything that Django extensions provides you. So I can do plus.user.objects.all. Okay, so you can see I already have it. I don't even have to remember the imports, which is, let's face it, if you have a big project like Kraken, or I'm sure some of the others that I've talked to tonight, remembering the import path can take a while. Now you don't need to remember. You can forget. It's pretty nice. Okay, so let's see. The only problem though is if you look at this, and this is what you get in Django extensions, this is only so useful. You can't actually read the data. Well, let's fix that. Oops. There we go. Oops. And I just entered some errors. Okay. Okay, so if I do plus.read frame, okay, and I run this, here we go. So what this has done is it has read in this Django query as a pandas data frame. Pretty nice, right? And if you, and I can also save it to a variable because this is Jupyter Notebook. So pretty awesome stuff. And then I think, can't remember if this sorts yet. No, it doesn't. That's right. So let's see, what else does this do? Oh yeah. So let's say I want to know some of the background behind this particular model, this user model. Well, I can do plus.diagram. Like, what does it inherit from? Okay. That's nice. Oops. Did I just? Oh, there we go. Okay. So as you can see, what it has done. Let's see if I can shrink this a little bit so you can see it. It's using Mermaid.js and some clever code to generate a class diagram of the user model. And it's you know, as long as you don't have a gigantic inheritance stream, it's really useful. Another thing that you can do, what's the next one? Oh yes, this one is really cool. So this is model graph and then plus user. So I can also look at the relations for this. there's limitations with this particular thing. At the moment, one of the challenges with using Mermaid.js, well, it's super easy to code to, it doesn't handle large charts well. And so one of the features that we're working on is getting Viz.js so we can have better representations and larger representations. The challenge with that is that it's not working in IDE. So if any of you are really good with JavaScript and Jupyter Notebook, which is an interesting combination, like come and talk to me because I could use your help. Okay, and then let's say, for example, now that we have, we know what this model looks like, let's say we want to know what exactly did we import into the plus object? Because when you start up Django extension shell plus, you get this nice print of this list of everything that's been loaded. Well, we have that too. Oh, sorry. There, is that better? Here, I'll run it again to show that it's live, that I'm not like. Okay. So as you can see, we have Django extension shell plus. There's a lot of subtleties that we use. If I go to a big project, let's see. So I'm going to do Kraken. This is actually the example that I made in case I didn't have hands free. Thank you. I'm not going to show that much data. He's giving me this look. Are you giving me a look? Okay. But I can show you some other features that I can't show you with the toy project, like what I was showing, because Kraken has 4 million lines of code. Load it starting up shell plus takes a while. So as you can see, we're using rich to have to show that there's progress being made and loading it. So there's all kinds of subtle features that we're working in because some of us are using this in Kraken. And so now it's activated. I'll show you what, let's see, this is not a bad one. Here we go. So as you can see, this is why I was saying, this is why I want to use Viz.js. This one, the brand object showing the chart isn't bad. But if I do the support user, it's even warning me that's too large render. And I don't know if you can see this, but there's this white line. That's a chart. That is, I think there's I don't know, 300 Anyway, the dream for this is to be able to provide, if we can use Viz.js, then we can also specify with the model graph, we can say, hey, I only want to load this frame of reference or have a depth. Because I don't know if any of you have ever run Django extensions when you graph out the architecture and it uses GraphViz, which is my favorite graphing library ever to render it out. Like for a large project, let's say Kraken, it'd be a poster covering that wall. It's almost unusable. So to me, the dream is, and I've tried to figure out how to make this work with Django extensions, but doing that in Django extensions is hard. But my dream is to make that possible. So please use DJ Notebook. Let's see if I can get back to the slides. Okay. What's that? Oh, yeah. So yeah. Sorry, live demo. Wow, that is super scary. I've not done that in in front of a live audience. I've only done on the web. At work I did a tech demo of this. So it's really, really scary. But yeah, please try it out. Give me your thoughts. Open up issues. If you want to contribute, if you go to the site, you can see I am really good. Or if you've read our books, I'm really good about attribution and sharing credit. Together we can accomplish awesome things. And so, yeah. So thank you all for listening. Okay. Any questions? Yes, sir. The question is, because I know Sarah wants probably wants me to repeat the question is, can we use it within a container, let's say with Docker or something like that? I think so. I have not tried it. In the work that we typically do at Kraken, which is where I do most of my code that might ever use Docker, we don't use Docker. So if you want to try it out and let me know how it goes, that would be awesome. The rules would be, I think, pretty much what you do with a regular Jupyter notebook. Okay. Who's next? Anyone? Any features that we should add?
I'm interested in the Vim, integration.
So my knowledge of Vim is from when I have to like shell into things that I don't set up myself. So I'm not a Vim or VI expert, but it sounds like you are. So I assume that means you're going to be making a contribution.
I'll challenge accept.
Okay. Yes, sir.
By curiosity, why this JS?
That because it's a neat library. It's plain JS. So like as much as I'd like to use GraphViz for this, I can't be certain that everyone who installs Jupyter Notebook also has GraphViz installed. If you know of a better JavaScript library for this, I'd love to hear it, because the fact that it's not rendering in VS Code is been a challenge.
No, I was asking because I actually did something like making a widget that displays a graph and a graph like
At the Jupyter Notebook.
Yeah, in a Jupyter Notebook.
Can we talk afterwards? I'd love to. Yeah, definitely. We're going to talk. Okay. Anyone else? Okay. All right. I think that's it for me. Thank you.
Maybe. So we are done for the talks. So now place to networking and eating, of course.
Only because I suddenly remembered that she was called integration test at all. It's failure to watch the audio. Something cost a lot.
Un micro magique.
I think